Right, so question 3 is a parallelogram. We've got, it's probably going to be to do with angles and the parallel lines. F is a point on AD such that BFE so is a straight line. So the line from B to E is straight, and F is on that line. Angle EFD. EFD is 35 degrees. Angle DCB is 75 degrees. Show that angle ABF is 70 degrees. So this is probably going to be angles on a parallel angles in parallel lines. And what we've got as well is two sets of parallel lines. So what I'm going to do actually is pause the video and get something that I've made in today, another lesson on this topic, which is quite useful. So let me just get that now. So basically in angles and parallel lines, we have the corresponding angles, we have supplementary or co-interior angles, alternate angles. And what I've done is with each one of these, I've tried to highlight the differences and how we can identify what's what. We want to, so before I start looking into that in a bit more detail, let's just identify what angle are we investigating. ABF. So this angle here. So we're trying to find out whether or not that is 70 degrees. Well, let's see what we can do here. So we can see that that angle is going to be 35 degrees. I also know that this angle, oh, okay, we've done it, I think. Oh, no, hang on. ABF. Okay, I know that that angle should be 35 degrees. Oh, I see. And okay, so that angle is 35 degrees because it's would be alternate to that angle, and that angle is 30. So this angle is 35 degrees because it's alternate to this angle, and this angle is 35 degrees because it is the opposite angle to this one here. Whenever you have two intersecting lines, the opposite angle is always identical. So lastly, we can do this angle here because of the other two lines, A to B and D to C, or in fact E to C, are parallel. So because they're parallel, this is a bit difficult to explain. We can imagine the B to C is the line that's sort of cutting those two lines across. Maybe it's a bit better if I highlight this in yellow. As you can see in this line up here, what I've done is the parallel lines are the ones in yellow. So we want to look at this angle, this one here. If I rotate it, it's a bit easier to see that. And maybe if I turn it, it's not. It's a bit difficult to see, but now in this part, I'm now treating that line there as the line that's cutting these two parallel lines, and so I'm seeing that this angle and basically this angle are co-interior, which means they will add up to 180, and because that angle, the one that I've highlighted in red, is this angle plus this angle, then I could say, let's call that one x, which is what we're trying to find out. And I would be able to say that x plus 35 degrees plus 75 degrees is going to equal to 180 degrees. And so I can say that x is equal to 180 degrees minus 75 degrees minus 35 degrees. And let's tap that into a calculator. 180 minus 75 minus 35 gives us 70 degrees. So the reason is going to be the hard bit here. So how do we explain this? We can first of all say, annotating the diagram is going to be going to help you with the reasoning here, because you can refer to the things that you've labelled on your diagram. And also using the three letter notation of referring to angles. So when I refer to this angle here, I can call it FBC. So I can say FBC is 35 degrees. I could, when referring to this angle here, I can call it AFB. So I can say that AFB is opposite angle, or I think they often call them vertically opposite angles to EFD, and so therefore identical. And then I can say FBC is an alternate angle to AFB. And then I can say that ABC, which is the red angle, which is comprised of these two angles, ABC is co-interior with BCD, this 75 degree angle. And then say, so they would add up to 180, and then you could show the calculation like that, and then rearrange it to show that that's 70 degrees. Okay.